start coding, I could go. Yeah, but you need this to make sure you're writing it correctly. So. I don't have whatever Java it is. Maybe I was gonna leave it. Organization is, because to be perfectly honest, I only kind of do because I wrote this 6 months ago. Kind of went through it. I mean, the first part is just mainly review, like not coding anything. So we can just switch off slide by slide. Right. We'll go just giving like a general overview of Java and why it's important and whatnot. Okay. This seems less hot. Okay. So it's like a map set code file. So program contains from one file several things that we code. Okay, blah blah blah. Class goes to one file. That makes sense. Enums shades. Applications override, global container, polymorphism, inheritance, extension. I'm glad you take the enum ones because I'm not very good at those. Okay. Where is it? Enums. Polymorphism. Interfaces. I don't remember regular. I don't remember regular space. Do you remember regular space? Go back to it. These are Well, we can say we'll just cover very briefly because they don't really need to know this until system software. Yeah. I think won't even need to know that. Okay. So probably need to put this on yourselves. Clip it on your shirt. Make sure it's not underneath your chin. They're sensitive, so mine's here. Can everyone hear me? Can you hear me? Thank you. All right. Can everyone hear me? All right, so we're good? Thumbs up, thumbs down. Oh, very great. Reactive. We're streaming already? Okay. All right. At the end of the session, if you guys wanted to give a review of how amazing we were. Yeah, I was talking about this. Sorry about this. Oh, you need to talk about that first? Yes. Okay. Sorry. At the end of the session, if you want to review us, tell us how bad we did, how good we did, hopefully how good we did. There's a QR code here. You scan that, and it takes you to a survey about this session specifically. So make sure you stop by here at the end. We have it up here. And that's all we're going to use the doc cam for. So now we can switch objects. All right. There we go. Okay, so welcome to the review for COP 3330, Object-Oriented Programming. If you are not here for this class, I'm going to have to ask you at this point to please leave the room. You can come back when we're done. It'll be a 2-hour session. All right? So I don't see anyone getting up. I guess you're all here for us. Can I get a quick show of hands if you're in Dr. Glinos's class? Okay. And hands Whiting's. Down. Who is in Dr. Whiting's class? Is that nobody? Okay, I see one. One person. Okay. Who's the rest of you? Ooh, what? All right. Next slide. All right. All right, so object-oriented programming refers to a certain type of programming. The class is not called Java, right? Because this is actually not just a class where you learn how to write code in Java.
There are several really key concepts to object-oriented programming that you're here to learn, and we're going to try to focus largely on those concepts. We are going to write some code while we're here. We're going to put it up on the screen. Unfortunately, we can't compile that code because this computer that we were given doesn't have a virtual machine, so we're just going to write it in Notepad. It should be helpful anyway for you to see what's going on. All right?
If you have your own IDE, you can copy it into that and then run it and see if it works. It should work, but then you can play around with it there.
If we make any kind of silly syntax errors, by all means, let us know and we'll fix it. All right. So the object-oriented programming languages include a lot of languages like C#. These languages are the ones you are most likely to use in the workforce. Most companies where you get a job writing programs are not going to have you using low-level languages like C or even like assembly. Nobody writes assembly anymore. So the purpose behind object-oriented programming is that it provides a higher level of abstraction than most types of programming languages. All right? The abstraction in this case is that it allows you to not worry about what is going on inside the computer. The more complex of a programming language you use, the easier it is to focus on the math or whatever it is you're trying to do and not have to worry about what is going on. All right?
Next slide.
Yeah, go ahead. Okay. So there are three primary types of errors that one can have when they're writing code. You can see them in these slides right here, which we will maybe try to make available to you if they're helpful. You got compile errors. This is what happens when your syntax is wrong. You have runtime errors, which are often a little harder to find. All right? Most errors are probably going to be runtime errors. Runtime errors include when you go out of bounds of an array or you try to write to a pointer that is not there. Okay, yeah, output errors. Output errors means that the program is working, but your output is wrong. This means you probably don't understand some aspect of what you did. Do you want to talk about?
Of course, we're specifically talking about Java, which is the language that you guys learned in this class. Like we said, the class isn't called Java, but everything is written in that language. There is a lot of things Java can do compared to C, which I know all of you had to take an intro to C before you took this class. C is a very low-level language, like David said, while Java is a higher-level one. It has a lot of pre-built functions within it that will do a lot of the annoying things you had to do in C by hand. They'll do it for you. While this is great, and it makes writing code a lot easier, it does make it harder when you don't know exactly what you want it to do or what it can do. Luckily, there is a great resource that Oracle, the people that made Java, have. It's called the Java API, and it's just a list of every function Java comes with. You should be using that whenever you use Java, just because there is no way you can feasibly learn everything Java can do and memorize it and keep it in your head. So it's a good way of like going back and making sure all your work is right and you're using appropriate functions. Oh yeah, sadly we won't be talking a lot about being a good programmer. We're going over the specific things in Java.
All right, and yeah, we are at the moment still talking about how to be a good programmer. We're not going to do this for much longer, I promise. All right. We already talked about this. All right, so we were talking about abstraction. All right, and up here on these slides, I have an example of the kind of abstraction we're using here, where C is kind of like learning how to drive a stick shift. When you come to school to study computer science or computer engineering, it's important that you understand how a computer works, and that's why they make you do all this stuff with linked lists and pointers and manually allocating memory. It's a huge chore, but it's very valuable information. Fortunately, Java is like an automatic car. The real world is full of automatic cars. You don't have to do all that stuff most of the time. It's just helpful to know how it works on the underlying machine. All right, let's go ahead and start talking about the things you actually care about for the exam. All right, Java has some fundamental concepts that allow us to create abstraction, right? These are called classes. We're also going to talk about objects and methods, which are directly related to classes, okay? Objects are an instance of a class. Whenever you create a single copy of a class is like a blueprint, right? A class tells the computer how to make an object. And an object is a variable that contains both information and also methods. Methods are like functions that are associated directly to the object. All right? So it's important not to get confused about the terminology there.
Objects, like you said, are a specific kind of variable. Kind of like you would make an int or anything like that, except objects can be whatever you want, and these can be edited, and you can add more and more things to make them as complex as you want. And it's the real strength of this kind of language. You can make things that seem more real than just a bunch of numbers on a text document. They contain data, and they can also contain methods within the objects. And you can call those at any point in time. Methods are essentially the same thing as functions, as you learn them in C. And each object has its own dedicated methods that only that object can use. This is where the static keyword comes from. Non-static methods are variables associated with the object. Static methods are variables associated with a class as a whole. Essentially, what's the easiest way to say it? Simplify it down.
Sorry?
Non-static methods can change and static methods cannot. Kind of thing.
Okay, so should we start writing code now?
Sure.
All right. So we are going to be writing code while we do this. So let's go ahead and get started. We're going to show you examples of these different types of methods, okay? So let me see over here. All right. Start with main. Do you want to tell them what main is?
Main is the main function of our program. It's the thing that tells the rest of the program what's going to happen. And this is the line of code, or this is the area like you would have done in C, where is your main function, where you put everything and it calls all the other functions. It's going to call all the other objects we make. Like we said, most of what's done in Java, it's going to be like every object has its own text file, and they're separate. Main is what puts everything together, and it's going to make it into a runnable program. So what David's doing right now, he's making a class called bro, and he's going to put the main string in this class.
Can everyone see
Or do you want to zoom in a little bit?
the code that I'm writing, or is it too small?
I think we can zoom in a little bit.
Can we make it bigger? Yeah, we can try. Can we just change the text font size? Here, let's.
I don't know that. Notepad is hard. Oh, wait, font.
Font. All right. Yep. Better? Thank you.
Good? Okay.
Okay.
So everything he's writing here is essentially the basic template of a normal main function, the public static void main string, the little brackets, args. It might look confusing, but that's essentially what you have to add. It's the same thing for every program you write. It's going to be the first line. And then you're going to want to put the curly brackets.
All right. So what we're going to do here is we're going to create a class. All right. Creating a class called bro, and we're going to make some objects that are bro objects. All right. So let's see how we're going to do this. All right, the first thing that we have to do, let's say this isn't our main. We wanted to talk about main, but we'll make that later. So a class is a blueprint, as we already said. So here we're going to say a bro object contains, I misspelled it. A bro object contains variables, right? In this case, shades would be an object of a class called shades. We're going to have a private string, and we are going to talk about what the word private and public mean.
Yep.
Soon-ish. Name.
So essentially what we're adding to this is that every object bro has 3 different variables within it. They're going to have the kind of shades that they're going to wear. They're going to have a name, which is the name, and each bro is going to have his own battle cry.
All right, so now those are our
Those are declared
variables.
variables.
We're also going to create some methods. So let's say public bro.
Again, we'll go over exactly what public and private means, but for now, just notice that it's there. And then within the method bro, he's stating which variables he's going to pass through this function or this method, and these are called parameters. So this method is going to use the variable shades, which we're going to name s for the rest of this method to make it easier for us to write, and it's going to pass in a string name with the name. So for the rest of this method, anytime we want to use what we pass through, we're going to use s for the shades we decided to put in, and we're going to use name for the name of the bro that we're putting in.
I ended up hitting caps lock. I don't remember when I did that. Oops, okay.
Capitals matter.
All right.
What else? Just give David some time to write this.
All right, well, we're going to talk about the this keyword
I can
in
go.
the near future. Do you want to, I mean, we can do that now, but then we're going out of order.
Sure. Essentially, we're making a method that makes a bro with whatever variables we're passing through.
All right, so this right here,
Switch to the
what's up?
okay. Practice, yeah.
Oh, we're calling this, okay.
Switch to
This right here is called a constructor. Every single type of class that you are going to instantiate needs a method that is a constructor. What a constructor does is it allows you to create an object of that class, right? So without a constructor, you have a blueprint, but you cannot use it to make a variable of type bro. You make this constructor so that when this method is called in another class, whatever we'll call main, we'll call public bro, and that will return a bro. And that bro will include this information, and it will have access to whatever methods we decide to give it. We haven't given them methods yet, but we will. All right.
Always remember, you need a constructor to be able to build an object. That's why it's called a constructor. A constructor. You're building it. So it's the thing that is most easily forgotten when you're writing code is you forget to add a constructor.
All right. So a bro object is going to have access to 2 more methods. One of them is going to be static. One of them is not. All right. So we're going to explain the difference between static and not static right now. Bro down. Do I want to do? Yeah. Okay. Yeah. Okay. So let me finish writing the methods, and then I'll explain.
So the whole public, or the public, oh no, this is accessibility, not actual. I could talk about accessibility. The whole thing that public, private, what those mean, it's called accessibility. It's essentially letting the program know what it is allowed to use, when and where. Public means you can see it anywhere in the program, and you can use it anywhere in the program. We're not talking about protected. And private means it's only visible in the specific class. So all these methods we're putting in here, public bro out, and public static, or public bro down, we want them to be visible in other classes because we want to be able to call them, so we make them public. All the variables we're making for this class, we don't really need them anywhere else, so we're going to make them private, so you can't use them outside of the class bro. So if you try and use shades outside of bro, it's not going to work. While you can call these methods anywhere.
Yeah. All right. Yeah. Okay. Did I do something wrong? Did I make it? I did, there's an error. Okay, this right here should not be capitalized. All right.
Shades is capitalized.
What, this?
Yeah, that is capitalized.
That's right, right?
Yep.
Okay.
You're right. You're correct.
All right. So now we're going to, let's see, where are we in the slides?
We've kind of hopped around a bit.
Yeah, I feel like,
Or we'll try and.
I feel like as far as the slides go, we've just kind of totally abandoned any kind of order. Is this helpful so far, though, writing the code?
There's one nod. We're good.
One nod? Awesome.
That's
Okay.
And we're
All right.
solid.
So we're going to talk about static as well. So this is a very important concept. I feel like a lot of times people will get confused. They will think that static has anything at all to do with access modifiers. Camilla told you about public and private. These are access modifiers. Static is not an access modifier. All right. Static tells you whether or not the method is associated to the class as a whole or is associated to an individual object of that class type. All right. So in this case, I haven't actually filled in both of these methods, but bro out, as you can see, is not static. That means an individual bro object is going to have its own copy of bro out. And when you call it, you're going to have to call object name, right, a specific object, dot bro out, okay? For static bro down, you're actually going to call bro dot bro down. It has nothing to do with individual objects. It is associated to the class as a whole. And each one does not have a different method, right? If we were to make a static variable as well, for example, if I go up here and I say public static bro count, except if I don't spell it terribly. Excuse me. We're being mature. Okay. All right. So the static variable bro count does not associate to any individual bro object. For example, if we were to keep track of how many objects that we have instantiated of this class, it would go there, right? This would be completely separate from the individual object, whereas every single bro will have its own name, shades, and battle cry, all right? So this should be a semicolon. Why don't we go into the slides and talk about some stuff? All right, talking about objects. Strings. All right, do you want to talk about strings?
Yes.
All right.
One of the, at least personally, my favorite part of Java is, if you guys recall, back in C, when we wanted to use strings, you had to make an array of characters, right? Strings are a thing in Java. You can just use them. You call them with capital S, string. Like, that's the kind of variable you make them. And they have a bunch of methods that you can use to, I don't know, sort it, make it, like, take out all of the punctuations, things like that. I don't know if you ever had to do something annoying, like I need to move or, like, reverse a string. And in C, you would have to take this array and actually, like, manually move each one to a different point and, like, swap them around. In Java, you can just do string.reverse. And that's it. It's done. Strings are used for pretty much everything. And the fact that they make it so easy to use is why, one of the reasons you want to use a language like Java for more programming, for bigger projects, so you don't want to have to deal with these little nuances when you're trying to do something very important.
Right. So strings have elements of both objectness and primitiveness. They do have methods associated with them, like an object, but you can use them a lot more easily than an object. You don't have to make your own, right? It's pre-built in like a primitive. So
when he says primitives, he is talking about like int and char, these things that are just built in with the program, things you don't have to like create.
All right.
And then, are you putting on a string?
Am I printing it? Yes. Yeah, I am.
So what you're seeing right now is kind of, you probably run into this before, but it's the formatting you use for print line or print statements in Java, where you can do a variable, or not a variable, where you can something plus a string, and you put the string in double quotes, and then you can just keep using the plus sign to add more and more variables or object names or things like that that you want to put in this big string. And if you were to print this out, it wouldn't print out the plus signs or anything. It would print out the name of the bro you're passing through, says that that end double quotes to, and then it's going to just say the name of whoever you're calling.
This is actually called concatenating,
Yeah.
right? And I believe in C there is actually a thing called string cat. That's what it does. Here you don't have to do that. Here you just do this, it does it for you.
Like a lot of things, Java does it for you.
All right. So let's say system. All right, what comes after strings?
I don't even remember. Classes. We
already talked about that.
We went over methods, we went over accessibility, we went over constructors, method overloading.
Method overloading. Okay. So, method overloading. Whenever you call a method in Java, you have what is called a signature. All right. So if you look here on the screen, can you guys see the little, see the mouse pointer? Yeah. Okay. So if you look at, say, this, that's the signature. Okay. The signature involves both the name as well as the variables that are being read in, the arguments. And so you can actually have different methods that have the same name but have a different signature, and they will function differently. So we can add public bro and have it just read in a string dot name, right? String name. And if you then call the constructor from outside this class will automatically know which constructor you're talking about based on the variables it reads in, right? So if you read in a name and no shades, what you will get is this constructor. And we can put in this constructor let's put a default shades for when we are lazy. So shades equals, and we're going to show you guys in a second what on earth we're doing with shades. We actually have an enum that we're going to make. So hipster shades. All right. So we should also add in here this dot name.
But as far as method overloading we was talking about, that's essentially it. You can have things that are the same name, but if the parameters are different, you can call that specific one by calling that signature.
Another common technique whenever you're doing method overloading would actually be, rather than doing this, what we're doing here, and this assigning a default shades, what we could even do is say bro read in all right. So you see what we're doing here? We're actually calling the other constructor from inside this constructor and reading the default in that way, right? This is a valid thing to do. It's actually very handy for when you have a whole bunch of different possibilities, all right? So let's go down here.
The next thing was switch cases.
Oh,
no,
I
importing.
have with the import stuff. Okay, so we also need to talk about input output. because I'm actually already writing code to do system.out, but that's not going to work on its own, right?
Yeah. So we're calling things that we necessarily don't have because we haven't imported anything yet.
Okay, so at the top of any code you write, you're always going to have import of Java libraries. All right, this is where you get all of your pre-built-in methods and classes and functions and all this stuff that Java has for you. You have to tell the computer where to find it. So something we might need is java util.scanner, arrays, with a big old list of things.
If you're lazy, you can also import the whole thing, and I know we promised we weren't going to talk about how to be a good coder. That's bad coding.
Yeah, you don't.
How you do that, you just put a star. That would import all of the util folder. But you're not going to use all of it. So there's no sense in importing the whole thing when you're only going to use a couple.
When you're writing
functions.
code for a job where you need it to run quickly and efficiently and not waste time and energy,
You don't want to import garbage.
yeah, it's a waste.
What else? Lists.
Make sure to do io.printstream.
Print stream. Do you not use print stream here? I did. I'm just making one. I always do that. What is it?
Java.
The last one I'm missing is array lists.
All right, yeah.
Array lists and that's not the same one.
We have a caps lock problem.
Oh my god. Then IL.
All right, yeah, because we're going to do files in a minute. All right.
I did the thing where I'm bad.
Okay. I'm going to do this for technicality's sake. All right, so the next thing we're going to talk about is switch cases. All right, so we're going to introduce another method in here. You see over here where I call the battle cry function, right here. So,
You guys have probably seen switch cases before. Like a menu of options. So what he's going to do is which one are you making?
battle cry.
Okay. Yeah. So he's going to make a method that he can only call in this class. This is where it really matters. And it's going to pass through the kind of shade, because we've decided that the bro's battle cries determine what kind of shades he's wearing. Good. Curly brackets.
All right, so
Sure, read. So this is how you start calling a switch statement.
switch cases are basically a series of if statements. It's just a faster way to do it than writing if a whole bunch of times. You don't ever actually have to use a switch case, but if you want to be good at programming, you really should know how.
It makes your life a lot easier. Instead of having to do, if it's this, then do this, if, over and over again, you just make separate cases, and if it's this case, I'll automatically do what's under that one. So, for example, since we're touching on the kinds of shades, first case is aviators. So, if aviators, it's going to print out a string called return. And the battle cry for a bro wearing aviators is I'll be back. And then we want to break it.
So you always put a break statement in every single case, because otherwise it will just check all of the others. Now, checking all of the others wouldn't result in you getting wrong input, because you're only going to have one shades, but it's just a waste. again, you don't need to check them all if you know that they're not going to be valid.
Yeah, if you know the case is aviators, you can stop right there. You don't need to go through all of them. Because remember how code gets read from top to bottom? It's going to run through aviators first. If it's wrong, it's going to go to the next one. If it's wrong, it's going to go to the next one. If you don't put a break statement, then even if aviators were right, it would still check through all of them. And you'd just be wasting runtime. Or you'd just be wasting space. Don't forget to add
Right.
user shades.
Right. We need a battle cry for the hipsters. Oh, we can't. I think you're right.
Alright, and just so you know, don't get confused by the fact that he's adding return. This isn't like method return, this is the name of the string he's using.
And we are going to return this string at the end.
You had a question? That's what I was talking about.
String is just the name of the string at the moment.
Yeah,
It's
he can
going
name
to
it
be
whatever
returned.
he wants. He just decided to name it return because that's what we're going to return. It's not return as in the return. It's just the name of the string.
We're actually going to end up down here with a return.
Yeah.
Okay?
We're gonna
That
return.
is saying we will return the string that is called return.
If we want, we can change the name of return.
Yeah, we can change the name if that's confusing. Name it yay.
I'm lazy. I use control.
That's fine.
It's the same thing. Well, you can name it whatever you want. Any other questions about this?
We haven't lost anybody? If so, say so. Yes. Is that true? That might be true.
That
If
might
so,
be
we're
true.
sorry, and we will stick with swag money. This dot battle cry is referring to
The string.
okay, so is this what you're talking about?
Because the lowercase
Okay.
lowercase one is the string.
The string battle cry is lowercase b, right? Down here? Is that what you mean?
No, it should-
Okay, is it better? It should be. So capital B battle cry is referring to this method right here called public string battle cry. And we're saying that the string is equal to the return value of the method. All right? Okay. Everyone's with us now?
Yeah.
We're good? Okay.
Capital,
continue.
like capitalization errors and things are really common, which is why you usually do this not in Notepad.
Yeah, thank you very much, by the way.
Yeah.
By all
Sometimes
means,
it's hard-
if
it's
we
hard
mess
to-
stuff up,
yeah.
call us out.
Because if you were trying to run it the way it was before, it would not run. It would mess up. So, good catch.
All right, so we added, what is it we added? We added lens list.
There we go. So import statements we did in switch cases. Loops and arrays. Do you even
Loop.
use loops
Loops and arrays.
in this example?
Go ahead and dig through it for me.
Alright,
Do you?
well, loops, we're going to talk about loops first. Loops work the same way as they do in almost every programming language. The syntax is just different. There are three basic loops that are in every language. You got your for, you got your while, and you got your do while. Each one does a different thing for different scenarios. For loops will run through whatever you have in the for loop as many times as the parameters you set for as many iterations as you put. So you will determine a variable, and it will determine how many times it'll run. So while this variable is less than 20, and then the for loop will run 20 times. While loops will only run while the statement that you put in it is true. Or, yeah, it's true. So if you put like a while loop, like while the number is less than 50, it will run until the number reaches 50, and then stop. Do while is pretty much the same thing. The only difference between while and do while is that do while will run at least once, and then the activation of the while statement will happen. So with a while loop, if your statement is false, the while loop will never happen. But if during do while, it will happen at least once, and then it'll check if the statement is correct, and then we'll run through it.
All right, so briefly, notice that in our switch case, we have a default. You need to have a default whenever you're doing this, or else everything might explode and you'll die and the world will, end. The default is basically in case none of the above is the correct answer, it knows what to do. So in this case, we're actually going to say that the default is nothing, all right? Which is fine, because this right here is actually a string. It's just the empty string. All right, so let's see.
Keep going.
Yeah. Okay, so we're probably going to do files next. All right.
Yes. That's the point.
What are files? Really, these slides stuff. Let's just stick to our code. Okay, so up here we have Java import IO. So let's say that we have file. All right.
That is just fine.
Yeah. Let me see. What are we reading in from? Okay, yeah, this is what we're going to do next. All right. This is right. Okay. All right. So here we have a pretty complete looking bro class. You'll notice that this actually did not include public static void main, right? I never included it. We can go ahead and put it in though. So I did, but we don't have to have a separate one for main. Whenever you're running a program in Java, it's different from C in that it does not necessarily start at the beginning and just run to the end, right? What it does is it starts at main, and then it goes wherever main tells it to. In Java, you're often going to have many files working in tandem to form a program, and so it is not necessarily going to be linear like we're used to it being in C.
Now, this does lead to one problem. You can't have multiple main functions. If you have more than one, you have to delete one, or everything's going to break. Because the compiler won't know where to go. It's going to try and go to both, and then it can't do that.
All right, so the first thing we're going to do in main before we create a bro, all right, is we're going to create a scanner object. All right, so whenever we use the keyword new, what we're doing is we are telling the computer that this is a constructor, all right? It's telling the computer we need to create an instance of an object. Up here, we have the import for java.util.scanner. This allows us to access the method in the scanner class that will create an object and return it into this variable, right? We don't have to see how that works, which is the point behind Java. Remember, automatic car. But we have to know how to use it. So the scanner is going to read system.in.
For those of you who don't know exactly what a scanner is, it's exactly what it sounds like. It's going to read through a file, usually is what you use it for, to read through a file for certain things. So when you're importing things, you usually want to use a scanner. Oh, and system.in is the keyboard, system.out is the monitor. Just so you know. So
We
we'll-
can,
yeah. So what he's saying here is that the scanner is going to read in whatever he types into the keyboard next. Went a little bit ahead of myself, but yeah. Yay.next, so he's using the method from scanner that reads in the next input from whatever you said initially. So he said system.in was where we're going to be getting all our inputs. So user input. Yeah, there's different ones. There's next line, which reads in the next whole line you type in. So whatever you type in, hit enter. There is next int, which just reads in the next number. You can type as many letters as you want. It's not going to read anything until it hits a number. Next is just whatever gets typed in. Just period, everything that gets typed in. Yeah, super generic.
all right, one thing I want to cover really quick. How many people here have taken CS1? Okay, does anyone in here not know what a pointer is? Okay, so pretty much any kind of variable that holds an object in Java is a pointer, right? This is not necessarily true about primitives, but here we always have pointers. This allows us to do this. If I were to say, get rid of this, all right, and then declare at the top, or anywhere really, I could declare it separately. This is valid, right? The problem is if you try to use it before you call a constructor, this is a null pointer, right? The variable yay doesn't contain anything. Fortunately, unlike C, it doesn't contain garbage data, but it is still nothing. All right. So input. This is for reading in from the system.in. We're also going to read in from a file. In order to do this, we're going to need what is called a try-catch block. Do you want to explain what that is?
Sure. Try-catch is something you use to try and, like it says, catch errors. So essentially what it's going to do is it's going to do whatever happens in the try brackets, and if it throws a certain exception, it's going to catch it. And what it says, what that actually means is that it's going to go through this, and the exception we're going to use is file not found. So if there is no input, then it's going to say, hey, there's no input. And the catch statement is going to say, if there's no input, what do we do? It's going to print out there's an error.
Catch statements are designed because you do not know at compile time whether or not the file is there, right? There's no way to check. And so you have to basically tell the computer, hey, be prepared for this to maybe not work, right? We can't tell. And so you put it in a try-catch, and that way, if it's a file not found exception, which is what we would put, file not found exception,
I actually named this exception.
Hmm?
I just named it finish.
okay. If you get an exception, such as a file not found exception, the computer knows what to do, which in this case we would say system.out.println. It will work. Okay.
Sorry.
So.
Should probably also import file not found.
Oh, okay.
I mean, I imported stuff. But
All right, so you can see right here we're creating a scanner. We're creating a scanner object. And we're also, in here we have a nested new, right? We are creating a file object based on the input, right? So we have a scanner set to user.in wherein we read the file name. And then we used that file name to create a new scanner that is going to scan the file, all right? Did I mess something up? Yep. Okay. All right, is everyone clear on how and why we use a try-catch block?
Yes. Okay, so if it goes through the try part and it goes to make a new scanner, and the scanner is going to be a new file named user input .txt, if there is no user input, there's going to be nothing.txt, so nothing's going to be there, which is bad. So if that happens, it's going to catch the file. If that happens, it's going to throw a file not found. And the catch block is going to catch that and then say there's no file, so it don't work. It's going to be a null pointer. Yeah. Because we didn't initialize user input to 0 or to anything for that matter. It's just a null pointer. It's not like C, where if it were in C, if you don't initialize it, it's just trash data. It's just null. There's nothing there. This is you making the file.
What up?
This is you making the file.
No, this is me
Initializing
initializing some bros named David and Camilo. All right. So this is what it would look like to call the constructor right up here, right? String name, public shades. All right. Down here from main. This will call this up here, right? Jumping around a little bit, which will in turn call battle cry. This will determine the battle cry for each of our characters. So if Camilo is wearing aviators and I am wearing transition lenses because I am blind, all right, his battle cry is going to be I'll be back, and mine will be, what's that say? Okay. So let's see, we got try-catch blocks.
What else? We don't have arrays in the example, right?
No, we don't have any array
We'll
lists.
just go over at the end.
Yeah, we'll go back through the slides at the end. Oh, okay. Enums. We have to do the enums.
Yes.
Let's do that. All right. Enums is something that you probably covered briefly in CS1 or an intro to C, maybe. Did you? Maybe. Okay. Well,
Maybe not.
Anyway.
I think one assignment, at least from Gledos, required an enum, or didn't require an enum.
All right. So public enum. An enum is actually just a series of variables, right? It's variables that kind of fit a category, and it's set. Let's make some examples.
Just so it's clear, this would technically be a different file.
Yeah. Yeah, we would put it all in the same package, however.
Yeah. It would all be the same package, which is all the code, but the enum would be its own file. Kind of like we said how objects would tend to have their own files. Bro is an object in its own file, and we just happen to put the main in it. That's fine. Enum is a different file. We're going to use it in the main, but for the sake of it, it's going to be a new file.
Okay, so enums are going to be in all caps. However, as you can see, there actually isn't all that much to making a series of enums.
It's literally just put all the variables in the enum.
This right here,
And
this bit of
categories.
code, would be in its own file that has the name of the package at the top, all right? So
Yes.
let's see if we have anything interesting in here about enums. I think we do.
There's one
Oh,
slide.
here we go. I can take a look at that. For the record, everything that we're doing here is going to be streamed. It's going to be on the SARC YouTube channel. If you need to re-look at all this stuff, or if you want to pause it and you want to read our slides, you can do that on the internet, all right?
And
Yeah, we could probably get the slides.
Yeah. If you want the slides themselves, just come by at the end of this.
Yeah.
Write down your email, and it'll be emailed to you.
All right. I think
Right, same day.
interfaces is the next thing we need to talk about. All right, so we're going to start talking about polymorphism soon. All right, polymorphism and the extension hierarchies. This is a really key aspect of Java and object-oriented programming in general. So when you make your different classes, not all of them are actually designed to be turned into objects. All right, some of them are going to be either an interface or an abstract class, which we're going to talk about both of these things. All right, an interface, as you can see in our slides, an interface is just kind of a shell. Whenever you make an interface, it's designed to be implemented by another class that will make that class both itself and the interface. All right, so the program example that I usually use in Sark is the zombie dance battle program, where we make a series of objects, classes for a pirate and a ninja and a zombie, and all of them are going to implement the interface called dancer. All right, this causes them to all be both whatever they are, say a pirate, but also a dancer. This is important because this allows us to treat them as if they are the same object in some certain the same class, not the same object, in some circumstances. All right? So an interface, when you make an interface in code, there's really not a lot to it. I don't think we have an example, but if you've seen it, you have the names of the methods, but there's nothing inside of it. All right? All it is a blueprint for a blueprint. All right. An abstract class, all right. An abstract class is similar in concept to an interface. The difference, of course, is that it is not designed as minimally as an interface. An abstract class, we do have a slide for that.
Oh, here.
Yeah. It's further down. There you go. All right. It is similar to an interface in that you cannot instantiate an object of an abstract class. However, it is a lot fuller than an interface. It actually has a lot of filled-in methods and variables of its own. It's kind of a cross between an interface and a class. Usually, when you make an abstract class, the idea is that you're going to make another class that extends it, right? So when you call super, you could be calling an abstract class that is not designed to work on its own. You can also include a variety of classes that all extend the same abstract class. We're going to talk a little more about the extension hierarchy soon. It's a very important part of Java.
One good example of abstract classes, basically I like to say, is the vehicle versus car, truck, whatever. If you're trying to define in a program whether or not a car is a regular car or a 16-wheeler truck or anything like that, you can make an abstract class that is vehicle. And that class has, the amount of wheels, I don't know, different things that kind of specify what it is. And then a car would extend vehicle, and it would be more defined, have 4 doors, 4 wheels, etc.
There are plenty of examples of this in your notes if you need to look at them.
Or the Java API.
Or the Java API, always the Java API. All right.
Go back and forwards.
We have to go backwards a little bit.
All right.
All right, so whenever you extend a class, be it a abstract class or a non-abstract class, because you can extend a class that is not abstract, or whenever you implement an interface, especially when you implement an interface, we use the override keyword to tell the computer which named function to use, method, excuse me. So for example, if I were to make an interface, I don't actually want to type it up because I don't want to mess up the syntax and I don't want to say anything wrong. But in an interface, you would have an empty method shell, right? It would have the name and it would tell you what kind of things you're going to read in, but it won't tell it what to do. In the thing that implements the interface, you're going to have to put the full version of that method or it won't work. It's going to have the same name, the same signature, but it's also going to have to do things. we use the word override on top of the full method, so it tells the computer which method to use because they have the same signature, right? This applies even when it's not an interface. It applies if you use a class that has a full method, except you still want to know which one to use. All right, so there are two important things, two important classes that we did a lot of this semester, and that's comparing things. This is necessary for when you want to sort objects. For example, if we were to want to make an array of bros, we could do that. Let's do that. Let's go down into main.
Essentially what he's doing here is he's making an array of bros and he's naming it party time. I'm
Alright.
gonna put a limit
What's up?
to the size, or just gonna leave it.
Yeah, we'll say 2, because there's 2 so far. All right, so we can say party time, 0, all arrays start at 0, you know that from C, intro to C, equals, it's gonna be 3 bros? Oh, okay, that's fine. David.
And you guys are familiar with arrays, at least somewhat, from intro to C. I'm sure you've done them before or earlier in this class. But essentially all you're doing is making an array of objects, which you can do. The objects are bros. They were kind of like variables in that sense.
So,
Sorry, go on.
go ahead.
I'm done.
Okay,
That was it.
so if we wanted to be able to sort this array, especially say, pretend we had 20 different bro objects, and we wanted to sort them alphabetically by name, what we could do is we could cause the bro class to do one of 2 things, all right? One is we implement comparable, or 2, we create a comparator, all right? Comparable and comparator are both interfaces, however, we use them differently. When we implement comparable, the class we are comparing, in this case bro, will implement comparable, all right? Comparable is an interface that has one method in it, and that method is compare, right? Compare to, right? So what we would do, we could say, assuming that the bro class implemented comparable, we could say Camilo dot compare to.
Compare.
Huh?
Yeah, that should be.
Oh yeah, okay. Compare to David. All right. All right. And what this would do is it would return a number based on which one is larger. In this case, we would want Camilo to come first. So when you implement the comparable interface, you would need to include a method in your bro class. So let's say implements. Implements is the key word for when you do interfaces.
Extends is for abstract.
Extends is for classes, abstract or otherwise. So let's give all right. And so a lot of the times, okay, hold on. very important thing, override, okay? So whenever you do this, you actually get to decide how one thing is going to be compared to another. In our case, we're just going to do it alphabetically, right? But there are limitless ways to do that, all right? So I'm not going to bother coding it. You can do it however you want. That's the point. Yes? What? Yeah, we did that, didn't we? We put implements comparable after bro.
Yeah, you put it at the very top of the class when you call it the first time, like when you're naming it. Yeah, if we were extending some kind of class instead of implements, you would put extend and the class you're extending.
All right, and so you can implement as many interfaces as you want, but you can only extend one class. That's one of the reasons we use interfaces. What's up? I don't believe overriding is actually mandatory. However, it's important for whenever you want clarity, right? What the override means is it means to use this compare to method, because in the interface comparable, there is a method called compare to, all right? Now that one will not work, right? So you want to specify, use the one we made, not the other one. That's the purpose of override. The method in the interface is empty, right? If it were a class or an abstract class, it might not be empty, and you might not want to override it. That's fine. You don't always want to do that, right? But you don't want to use the broken one. Are they talking to me? No. Okay. All right. Is that clear? All right. Okay, so that's comparable. Comparators serve the same purpose, but work a little differently. And there's also, I feel like it's a common stumbling point in this class. People get confused about which is which. Comparator is an interface, but you use it on its own class, right? So we would make a class called bro comparator that would implement comparator. I'm not going to type code for that because I already implemented comparable, but a comparator, the way it would work is it would create an object that would have a method that would read in David, comma, Camilo, and spit out, the interior of the method would be pretty much the same as however we do it in comparable, right? It would do it alphabetically or however you want. It would determine that one of them comes first, right? So comparable, the class you're comparing implements it. Comparator, you must create an object that is a comparator and use that to compare your bros. Okay, let's see what's next. What do we got next? All right, so we've kind of already been talking about polymorphism, even if we didn't call it that. All right, polymorphism is just the way that an object can be multiple things at the same time, right? A bro is also a comparable, for example, right? Usually, we only extend one class at a time because things get very messy if we try to extend multiple classes. Like I said before, we use interfaces when we need to not extend, but implement more than one thing at a time. All right, I think we pretty much all talked about all this. All right, I mean, I think we've already talked about all of this.
Word for word, where you stuff to get messy.
Oh, yeah. All All right, yeah, super keyword. Super keyword is used whenever you have a class that extends another class. Basically what it is it's a shortcut to calling the constructor of the class that your class extends. Right, so if we had a class called person and we had our bro extend person, the first thing we would do inside the constructor for bro is call super. That way the bro would also be a person. And then anything that refers to a person would also refer to a bro because it is both. Abstract classes. We talked about exception handling. All right, so this is mostly for the students who are in Dr. Whiting's class, which I guess is not many of you, but you guys did a lot of stuff with GUIs this semester. I'm not actually sure how much of this is going to be on the final, but we're going to talk about it a little bit.
Yeah, we're going to do like a really brief overview of GUIs and kind of what they are. All
right, so the first thing that you need to know is that GUIs are basically a whole bunch of pre-built-in classes in the Java API. They're all in the Java libraries. So if you need this information, you can always find it on the internet, all right? You can always Google it. That's #1 advice for becoming a great programmer.
Learn to Google.
So the first class that you're going to need is you're going to need a J-frame, all right? The J-frame is the class that holds all the other things. You need to implement this. You need to make an object of type J-frame. It is going to hold all the objects that you're going to have visible.
I just want to make sure you guys understand what exactly a GUI is. A GUI is a user interface. I think it actually stands for graphical user interface.
Graphical user interface?
Yeah. So when we're talking about JFrame, it's the thing that is going to hold all the buttons and all the taskbars and all that, everything like that. That is part of the UI, and the JFrame is what holds all of it. And it works as a frame.
Right, and you have to make sure to set visible to true because otherwise the frame will not be visible. And then from that point, you're going to add to the J-frame all of the other objects after they are instantiated. All right, so some examples of objects that you might want are a J-panel. The J-panel class is designed to separate your frame into sections. It's an organizational tool. All right, and so inside each J-panel, because you can have more than one J-panel on a J-frame, you are going to insert smaller objects such as text fields, buttons, and labels. All right. So of course the reason for making a GUI is to allow the user to interact with it, otherwise it would just be a picture, right? So whenever you create a button or a text field, you might want to create an action listener. Action listeners are an object that is attached to the button, all right? So that whenever the button is pressed, it will create what's called an event. An event is an object, again, all right? And again, the class for it can be found in the Java API. I know the GUI section can feel like you're being hit with word salad, and so the best advice I could possibly give is to look at the API, all right? The action event will contain data about the event. You can use this if you need to access some text from a text field, right, for example. So you'll press the button and it'll read in the text that is in the associated field. And then that text will be in string format in the event object. The action listener is actually going to also have a method that will tell the computer what to do when the action takes place. This, of course, is up to you to implement. You can have it do pretty much anything you want.
The long story short of action listeners is you want them to be like, the button is pressed, do the thing. That's all they do.
Yes, it creates an object.
Yeah. They listen for the action, which is the button being pressed. And once they get that cue that the button has been pressed, they will run whatever it is you tell it to do. So if it's an exit button and you implement, when you click on it, it will run the method that exits the program. And that's about it.
All right, do we have anything else to say about that?
Regular expressions.
All right, so did you guys talk about regular expressions this semester? Yes?
Yes.
No?
Maybe.
Okay. So this is something they did in the past. I don't think they did it again. I don't think they did it this semester. But these are the symbols you need to know for regular expressions. I don't think we really want to. I don't think we really want to do that. Okay. So you got to do some multi-threading, right, at the end of the semester. Basically, how multi-threading works is it causes the processor to switch really quickly between several different processes. A process is something you will learn more about in the future. So a mono-core, right, a single core computer doesn't actually do more than one thing at the same time, right? However, it can trick you into thinking it is because computers do instructions so quickly that they can do thousands or more in just a split second and then switch back and forth very quickly. You can't tell that it's actually not working at the same time. All right, so let's see. Is there anything else we want to code in here? I don't think they do. I'm sure it was with C, but not Java. We'd have to install all that stuff. I don't think it'll let us. All right, so we're
It definitely was installing it.
no. We've done awfully quick compared to the last time I did it. I think it's because we didn't talk very much on polymorphism and extension hierarchy. All right, so we ended up going through this more quickly than we thought we would. We're willing to take any questions that anyone has at this point.
Formal definition for polymorphism.
Sorry? Formal definition for polymorphism?
I think, and I don't know word by word, but I think it's an object's ability to implement and extend different interfaces and classes.
So we talk about the is-a relationship, right? I think we have this in the slides. Let's go to it. All right, you're right. We don't have the formal definition in the slides. The formal definition refers to the is-a relationship that objects can have with other types of objects. When you have a class extend another class, any object that comes from that subclass is both types of objects, right? So, like what I was telling you before about my dance battle program with the pirates and the zombies that are also dancers, polymorphism, you know, the prefix poly means many, right? Polymorphism tells us that an object can be multiple types of objects at the same time. We can actually do
I found the word-for-word definition.
you can read that if you want. I can try to.
The actual word-for-word definition of polymorphism is the ability of an object to take on many forms. The most common use of polymorphism in OOP occurs when a parent class reference is used to refer to a child class object. Any Java object can pass more than one. That can pass more than one is a test is considered polymorphic. Yes.
Sorry?
I'm sorry.
What objects have to do with polymorphism as classes have to do with inheritance? Yeah, you could say that.
Yeah. Are you doing the dance class?
Yeah, I think so. Okay,
So the object ninja would be polymorphic because if you do the is a test, ninja is a ninja and is also a dancer. So it's polymorphic. It has two things.
okay, so let's make a copy of an interface up here. So public. Let's make sure I know the right interface syntax. Okay, so it's just interface dancer. Okay. All right. So all that's going to be in the interface is a shell. So let's say that it'll have the method dance. All right, dance. All right. So it'll say so no, it's not even going to have curly braces, just that. So this right here, if we were to read something in here, say int name, caps lock. This gives the method dance a signature. However, it doesn't tell it what happens when you call int dance, right? So what's going to happen is inside Ninja, we are going to have a dance method, public int dance. It's going to need to read in an int name. Except this one's going to actually do things, unlike the other one.
And just so you know, the point of this program is to take the two different kinds of dancers, ninja and pirate, and compare which one is the better dancer, quote unquote.
So let's create a constructor.
Which is just, it's just like a number that is added, like whichever one has the higher number of dance skill wins.
All right, so let's talk about the this keyword for a second. If I were to, typo. If I were to name this the same power level, then this line of code right here is going to lead to some confusing looking stuff. If I were to say power level equals power level, right? So this one right here refers to this one right here, right? This is the argument. It's the thing that was read in from wherever we called the constructor. This dot power level is referring to this, all right? It's referring to the Ninja object's power level. So we're saying this variable right here equals whatever is in this variable here. All right, so we're also going to need
No, right?
wait, what?
If you made it static, you can't change it.
If I make this variable here static, it can be changed. That's not the same as final. Okay, let's talk about final. Static variables can be changed. The difference is that they would not associate with an individual ninja. They would associate with the class, right? So the common example of when you would use a static variable is if you were keeping track of how many objects you have instantiated. All right, so if we had, say, private
Essentially, if it were static, each ninja could not have its own power level. They would all have the same one. But it can be changed. Is what I'm
Right.
saying.
So final,
Final is the one you're thinking of, where you set it equal to something and that is never changed.
final is the equivalent of define in C. So if we said this, then it would never be able to change. All right? Is that what you were thinking of? Would that give you an error?
It would either give you an
yeah,
error
probably.
or that line would do absolutely nothing.
Yeah, it would, I don't know if it would break, but it wouldn't work, right? Like it wouldn't change the value.
Like, it might still compile, maybe. I'm not 100% sure, but it definitely wouldn't do what you want it to do.
Usually, sorry?
Yeah. All right. If it was like it is right now, where it's final and it's equal to 8, all the power levels of every single ninja will always be 8 and that cannot be changed. If you started off at 8 and you remove the final keyword and you do anything to change it somewhere else, it will start at 8. But if, let's say, like for every ninja you add 1, it could change. It could be 8, 9, 10, 1. It would change for each one. You couldn't call power level in, or another method, yes, but you couldn't call it outside of this class because it's private.
So good practice is whenever you use final, set it equal to something right away, right? Like don't do this,
That would break.
right? It's not good practice. So we were talking about making it static before. So we could say we have a private static. Actually, I have a better idea. To make an example, we will make a zombie dancer. And the zombie, what's up?
You're in the horde bonus.
Yeah, horde bonus. Okay. So, zombies are not very threatening on their own, but when they're in a group, they become very threatening. So, we're going to have a public static horde size. Okay. All right. So we're going to say that every zombie has a power level of exactly 1. All right? But the power level of any given zombie dancing, whenever it's compared, we can set it equal to the horde size. So the horde size will change whenever we create a new zombie. So once I implement comparable, what I can actually do is I can say every zombie is actually not going to use its power level when dancing. I can have it use this right here, which will mean every zombie fights the same.
You see, and you see how that brings up an example of how you use both final and static. Final will always be 1, no matter the zombie's power level will always be 1. But the horde size is going to keep track of how many you make. So every time you make a new zombie, you're going to add to horde size. It's going to increase.
All right. So let's
Does anyone else have any questions or anything they want to see implemented in this?
was the question?
Overriding, right?
You mean like when we use the this
We're
keyword?
talking about this, right?
You mean
when we're using this? What do you actually call it? That's a good question.
there is a word for that. Hold on.
There's definitely a word for it. I do not really know it off the top of my head.
That's not polymorphism. You didn't know it was. Shadowing?
Variable shadow.
All right.
Sounds about right. Has the word variable and something cool in it.
Yeah, I can't.
You know what variable shadow is?
Is variable shadowing a term that you guys actually used in class, or is this just something that you guys know? Okay. All right, in computer programming, variable shadowing occurs when a variable declared within a certain scope has the same name as a variable declared in an outer scope. So yeah, that's what it's called. It's variable shadowing. All right, so then we're going to do comparable. All right.
So what he's doing right here is he's doing what we talked about before, where you can implement multiple interfaces, and he's implementing both dancer and comparable.
All right, so we have to override compare to, right? So at override.
The compare function in each one, or
In each one, compare to, because so we're going to make a different compare to function for zombies, pirates, and ninjas, because they do not have to do the same thing. That's the idea here. The comparable interface does not contain any information. It looks like this dance interface, where it just says compare to, right? This is deliberately ambiguous. It gives you a lot of control over how the comparable is going to work, what kind of information it wants to look at, all right? So let's say...
And the purpose of that is because you want to be able to decide, like, how you want to compare them. Like, whether you want to compare them, like, alphabetically, or which one has a higher number, or whatever you want to use to figure out which one kind of quote-unquote wins. You can determine it right there.
So usually comparable is something we implement in one class, say the bro class, so that it compares bros to bros. In this case, we need to be able to compare zombies to pirates and pirates to ninjas, etc. The reason this is able to work is because they are all dancers, right? We are comparing the same things because zombies are dancers and pirates are dancers, all right? That's the purpose behind implementing the dancer interface. If you wanted, you could also create an abstract class or even a regular class called dancer and have them extend that. That would be fine too. In that case, you could actually make this a little easier on yourself and have dancer implement comparable rather than doing it in all these classes, all right? So how do we want to do this? How do we want them to compare? So let's read in dancer. What I'm trying trying to do is determine how I want to do this, which isn't really important, right? But I'm doing it for the sake of it. That's cool.
Again, did anyone else want like anything else implemented into this code, like as an example? Kind of like how we added the final static thing, because we were asked a question about it. How do you what? Like how to use it? Okay, what do you mean? Like, do you mean how we're in dance he has like int name? Because when you're in like making a new method, the like instantiation of that method, the first time you do it, it's going to have the name and then the parameters you pass through it. That first time you need to specify what kind of parameters you're going to put through it. So in that one you're going to put like int, whatever you want to call it, name, whatever you want to call it. And then when you actually call that method, you only pass through whatever you want to pass it through. And it's going to, let's say if you call the function dance and you put the actual name of the dancer, like the zombie's name is Blurred.
Did your mic die?
I think my mic died. Yeah.
Okay, what were you saying? Did you finish answering that question?
I think I did.
All right, that's not actually familiar to me. I don't think I learned it when I took the class, but we can do a quick Google search for you. That's fine. Give us a second. We're trying to deal with technical difficulties. Okay, so if you take a look here, I implemented compare to in all three of my classes, my zombie, pirate, and ninja class. And you can take a look here and see that it uses the power level to determine who wins for both these ninjas and the pirates. However, in the case of the zombies, I decided I didn't want to do it that way. I decided to do it completely differently, and that's fine, right? That's the idea. All right, so raw variable types. Raw variable types.
Cool. What do you do?
Raw variable types, because that's not familiar to me.
This is actually pretty cool.
Oh, okay. So when you guys wrote your programs, you made array lists of that contained objects, right? So you would say, let me see if I can just make this up on the spot.
I'll believe in you.
And somewhere in here, it would have something like, is this what you're talking about? Okay, so I think, where did you see that? Okay, I think T in that case was just kind of a placeholder. All right, whenever you do this, you use the name of a variable type, and it's telling you what kind of object the array list contains. So in this case, this is an array list of bros. We can make an array list of anything. All right, we didn't actually talk about array lists. Does anyone have any questions about array lists in particular? Because I think we have that in here and we didn't talk about it.
It would be all the way at the top. I lied.
All right, so if you've taken CS1, you already have an idea of what a linked list is. An array list is actually more like a linked list than an array. The difference is that it's indexable. Of course, an array list is a type of object, which means that it has methods. This is how it's indexable, right? And you can see down here that it's easy to convert to and from an array, but generally speaking in Java, array lists are actually very, very useful. Mostly because you can resize it. It doesn't have a set size when you create it the way an array does. All right, so we have about 8 minutes left. All right, does anyone have any questions they want us to go over? All right, well, we'll be here. We'll be here for the remainder of the time. It's a little under 10 minutes, but that's pretty much all we have for you guys, all right? Best of luck on the final.
Remember, if you want us to email you a copy of the slides or even this code, we could save it and we can just come up here, give us your email. We'll do that now. You good? Good luck.